Right.
Yeah, just right now.
Sure. See, I like.
All right. All right. So let's take a look at the application of op-amps, right? Remember last week we did op-amps, right? So today we want to take a look at the applications. I want to show you before we go back to the handle. Right? I want to show you three different examples, right? Three different applications. The first one is the comparator. The second is the which coming from now, please.
I could have done everything. You do what?
Coming from Cherish. All right. So here we have it, Cherish. Come on, please, come on, please. Come on, please, come on, please, Cherish. What? Come on, please, come on, please. Pass now. Come and keep my back. Quick. Nobody online, there's nobody online actually. But I didn't know.
Yeah.
So I have to like. Yeah, I'm going to speak to them. Yeah. Right, so those are the three different types of right? We're going to focus on those three types of op-amps. One is called a comparator. We're going to focus on that today. Probably the inverting too. And then we're going to look at the non-inverting, right? So these are the three different types of op-amps. You'll recognize that. Does this have any loop coming back? Right. So this is open loop. These two are closed. Anybody remember what's happened when it's closed? The gain is dropped. Right? The gain is dropped and something is increased. Frequency. Bandwidth. Right here. So these are the three different types of op-amps that we're going to focus on. right? As we said, these two have a lower gain. Right, these two look in our reach, area and our reach. Right? These two have a lower gain, right? And this is I'll show you what it will do. One thing I want to notice here, right? What is here? The input is run through the inverting terminal. That's why it's called inverting. The input is run through the non-inverting. That's why it's called non-inverting. Huh? Yeah. Right? So it's important that you understand and you can identify different types of op-amps, right? Right? The first op-amp is called a comparator. What do you think it will do? Compare, right? I will compare. Yeah, I'm gonna show you. Yeah, you're up. So these are the three types of op-amps that you have to.
Okay, so like that experiment, I think it's nice enough to kind of shape.
Yeah, you can take like this. It's not numbered. That makes. Yeah.
Maybe let's spend $100 every experience.
Yeah, you did on, but remember it's different. We are used to something different before. Now let's see. Six,
I would just like once. Wait, say wait in regulations. Oh, no, I hear really good one there.
Ready? All right, let's go. No, also get too long. Take a quick. Right? Hey, you want to push series here? Yeah, you can want to them in front. All right, so watch this here. So the first one is the comparator. What does the comparator do? The comparator, it takes the voltage in the inverting and it compares it to the voltage in the non-inverting. Right? If this value is bigger than this value, your answer will be negative V supply. Right? And if the inverting voltage, if the value here is smaller than the value here, then your answer will be positive Vs. So this comparator only gives you two outputs, high and low. All right. So this is comparable to what? If you only have two outputs, right? Like a gate, right? High and low. So the comparator is a device that can take analog data and give you digital data. That's okay, right? So this is the way the comparator works. It compares these two values. If this is bigger than this, the answer is this. If this is bigger than this, the answer is this. That's it. Right? So that's all you're looking for. Right? And I'm going to show you how to do that now. The inverting op-amp, we'll do the proof it, but the inverting op-amp follows this formula. Gain is equal to V out and V in. Right? And to find gain, for a inverting op amp is minus RF on RI. If you divide these two, you'll get the gain and you can find the output. Yeah. Right? And here, same formula, gain. Gain is still V out and V in. But in order to find gain for a non-inverting op amp, we have to prove these formulas. There's 1 plus RF on RI. Okay? So these are the three different types of op amp. We're going to go in depth into each one now. Right, copy them down. And let's go to the comparator and focus.
It's good.
I'll get this. You all right, so?
Yeah.
Watch.
It's complicated, right? Again, it's not fun.
Yeah, one of them people competition, like you look at it, I should my brother.
It's not his fault.
I didn't even begin.
We are, bro.
Yeah.
That's okay.
This is last year. Ready? All of you else, so any guess if you're ready? Ready?
So we walk up here and make a peanut right? Okay, so I wonder what I why is it see? Share on flat, iPad on top of the head, share on flat. I mean, we don't be the shit no one.
Right here? Outside? She already big and finished, yeah? All right, ready? So comparators. What about other public ask you all right, right? But anyway, all the comparator will do, as I said, it's going to compare the inputs in the inverting and non-inverting and give you the output, right? So let's take a look at the example below. You can see that?
Yeah.
All right. So an op amp with an open loop gain, right? The gain is so important, right? But an open loop gain of 5 by 10 to the 5 operates with a supply of 6, positive 6 and minus 6. What is the maximum difference between V plus and V minus if not saturated? Any ideas what I'm talking about it? Yeah, so it's just plus 6 minus. Plus 6 minus minus. Yeah, so you'll get 12 volts. Alright, so all we're really doing is we're using a supply of plus and minus 6 volts to figure out the output, right? Let me plug in some up a little. Watch this here. Well, you can see, no, you cannot lie. See enough, right? Right, Nalini, remember me to India again. Nalia, right, Nalia, watch this here. The voltage in non-inverting is 3.6 and the voltage in inverting, there's a minus sign there, is 2.4. What will the output be? The supply is plus and minus 6. All the output be. Yeah. No, that's not B in, that's B inverting. Sorry, that's non-inverting, and this is inverting. Negative sign is inverting voltage, and the positive sign is the non-inverting voltage. Which is higher? Nalia, which is higher? Which is the non-inverting. So what will the answer be? What will the output be? Shivish. Yeah, which is larger? The non-inverting is larger, so what will the output be? Positive. That's all you're doing. You compare them, and if the non-inverting bigger, positive supply. If the inverting bigger, negative supply. That's it. Right? Shivish, next one. Which one bigger, Shivish? What is B down? Which are the B's? Non-inverting or inverting? Huh? Inverting bigger, so what will the answer be? Negative. Negative. You get it right. Now listen. Get it right. Get it right. I can't look from up again. Next one. Next one. The more the answer, you got to probably write it to down. The supply is plus and minus there. Write down what the answer is. The first one is the plus, second is the minus. Write down what the output is.
The plus, B minus is inverting, right?
B minus is inverting. Write it down. So say the answer. And then you do part 2. And sorry, you do 4.
Which the function?
Sometimes you want TikTok, you know.
Yeah.
Huh?
Show challenge,
And they wherever you work in here.
doctor's thing.
That's why you work in? Diabetes something. And also I want to do something.
Yeah, they were in
Or then if I change lessons on Fridays.
Yeah.
I'll still be with them Friday now. So I don't make 10 to 12. I said picking on Tuesday.
Okay. Yeah, we are choosing one too. The ball you know, I might agree. On there. Right.
What's for the good night?
So we got one.
No.
What is it by one? Yeah, what is it?
My Tuesday. So that's Tuesday,
No, I just thinking by saying Friday for now, I just think.
Dari Friday better because after school kau baca nak boleh main.
Right, well done. Ian was part two. Because the inputs in larger, very good. And next one. Try. Which one larger? For the answers.
Oh, yeah, yes.
Positive. Okay, so that's basically how the comparators work. But the problem is it don't be so simple. Right? Just give you a graph. So instead of points like that, they give you a graph. So we're gonna use that graph now to try to figure out what the output is. Actually, no, before the graph. Should I give you the graph one time? Yeah, let me do the graph one time before I give you a calculation. Watch it here. Right? It's not color coded, but I just want to show you. I did color coded, right? So I am giving it two inputs. What's your theory? This is coming exam, right? It's exact question coming exam. Let's say I gave you an alternating supply in red. Right? Let's say I gave you an alternating supply in red, and that represents the non-input. Right? And I give you a straight line here in blue. A lighter blue. Next one. Yeah. Right. What's the audio? What's the two different supplies, right? One supply is always zero. And then you have a next supply that fluctuated. You see that?
Yeah.
Right. And here is an intercomparator. So you have an alternating supply intercomparator, right? That is the non-inverting terminal and the blue line. We have an inverting supply that's always going to be zero. Right? You have to draw the graph of the output. And the output can only be what?
Plus or plus.
Plus or minus, right? That's 6, right? Let's use supply as 6. So yeah, output should only be plus and minus 6. Alright? Right. Here's how we're gonna figure it out. Everywhere you all see the point of intersection between the blue and the red.
Yeah.
Right. Everywhere they intersect. Everywhere they intersect, we can draw a little line, right?
And I think you can see this.
But yeah, but I wanted to I want to highlight what's happening in between. Right. So Aaron, take a look at the first pairing. Take a look at this part here. Take a look at here, right? Which is larger? The red or the blue? Red bigger, right? So if the red bigger and the red is the non-inverted, what would the output be? Positive one. In this case, supply is what? 6. So it will be positive 6. Correct? So it will be positive 6. So how will the output look? Like that? Right? This is bigger than this, so the output is high. positive sides. That's okay? Michaela, next one. In between here now. Who is larger, the blue or the red? No? The blue larger, right? The blue larger than the red values, right? So would it saturate high or low? Low. Yeah? What about next pair arrival? So the output is those orange lines. But the purpose of the green line is just to show you when to compare. Okay? You always look for intersections and then compare. Okay? Right, the bad thing is the other two. This exact thing has come as an example.
Every time I
Yes?
become that,
But you know the answer.
one of the big actually.
Okay? So that is the output of a comparison. If those are the inputs. Are you okay? Right? Try what?
Generates.
Huh? You know, I'm gonna get one guess, I guess. Huh? Yeah. And I one. Draw the output of a comparator. Right? Same scale and everything. Draw the output of a comparator whose supply is plus and minus 6. Whose supply is plus and minus 6 volts. Non-inverting connected to DC supply. Non-inverting connected to DC supply of 2 volts. Non-inverting connected to DC supply of 2 volts. And an inverted sorry, and an alternating voltage and an alternating voltage and an alternating voltage connected to the inverting terminal of amplitude 3 volts. Of amplitude 3 volts. Use the same scale here, right? Right, so draw the two inputs first and then try and figure out the output. Yeah. We alternated.
So you feel like you go in that, to get with the great light, in the tree.
The alternated, the one that looks side up, right? The alternated is like you're right. Right there, two of the same scale, 1 centimeter is two whatever, two of the same scale. And on the scale, I wanted to draw a DC supply of what 2 volts. Yeah, and I alternated out to 3 volts. But forget the frequency, right? Forget the frequency. Okay. Take that many right, please. Okay, this going to get the bubble. Right, okay, you know the fish of it. Okay.
It's 6 months. I minus.
Right, can you alternative will just like that, right? Just not a- yeah, right. Yes, supply 6. So your output will be plus and minus 6. The wave is the alternate, then we have to 3. Alternating is straight and direct is About. Right, so the alternating going up to like 3 volts, right? Which one is the alternating? Inverting and non-inverting? Soraya? We didn't see. So the 3 volts is connected to the alternating supply is connected to the what?
The input.
So the inverting terminal, right?
They say that 2 volts is the,
So the 2 volts is connected to the
yeah, non-inverting.
non-inverting. Oh, that's a straight line. That's a straight line, yeah. Direct, you see. With the answer.
You can even put all this shape.
That's it there, right? Right, so now how do you compare again? That there is something you have to do before you start comparing.
The touch.
You have to draw the lines where they touch, right? So right where they intersect, connect them up. How the 12 group them, I think. Right, well, mine's not drawn to speed, that's why I had oh, you have to draw the outputs, then, Liam, what we have to know? You draw the output already? Which part, yeah, fire now. Fire. Huh? What's up?
Very good thing.
The yellow line, just look for where the red and the blue meet. So that I can compare between them now. Oh, yeah, draw the output, then the draw the output. I can wrong. Like back. Right. Let's do this one in full earlier. Right. Compare the first two. Wait again. The blue is in non-inverted, the blue is higher than the red. So it will be positive. Forget all that. Here. Maybe you'll look at that first part. The blue higher than the red. So you forget this, Soraya. And in the next part, red higher than blue, right? So saturate. Low. Right? Let's look at all the periods where it in between the yellow lines. Fix the diagram.
I get it.
Figure it out. Fire out. Yeah.
No.
All right. Not fire out. We got to turn up curve, yeah. Soraya, higher than. No. What you did not. One thing for the good. Yeah, I guess some people.
Yeah, period.
Huh?
Absolutely. That's your blessing.
So what do you have after? Full teacher curve, yeah. Right. So it went there, then you have the blue line here bigger. And then here the red bigger, so that's inverted, non-inverted, inverted, non-inverted. Have you look at that? So those yellow lines don't show them solid, right? Show them broken because they aren't really part of the graph, it's just a guide you. Okay? Okay, now, you okay with that? All right, come on, you go on to the next one. Yes. Are you okay with that? Got you. Shivish, how I get those lines? The yellow lines. Huh? Kiran, welcome. That's very. What? That's very true and push intersect, right? What would happen here? Suppose you have two alternators. What do you do? Two alternators. One leaf. Oh, you mean like, okay, suppose it look like this. I'm interested. Suppose it looks something like that. What you would do? Suppose it look like a green line. Well, it's the same principle. If it meets there, just where it meets, right? Just look at before and after and just compare it. So compare the red and the green line.
I mean, feel out the not in the
So if one of them, yeah, it's a little tidy there, right? But let's say you had that black line and you had this red line, right? Suppose it was a curve. Let's say. Let's just say it looks something like that, right? Remember, it's a comparator. So the comparator comparing the black and the red. So all you have to do is draw a line here and compare the black and the red. The black higher, put it to saturate higher. That's okay? Right? What do you mean? Yeah, the supply could be negative. It don't matter. You just find where the intersect and compare. All right? Right. So sometimes we'll get a supply that like that. Then other times they're not going to tell us the values. So other times they will have something looking like this. And it is much harder now for us to figure it out because we need to figure out what is the potential here and what is the potential here before we figure out the supply. All right. So we're going to do those examples. Those are a little bit hard. All right. I want to show you something called the potential divider before we do those calculations. Right. But the objective really is to find the potential here at A, find the potential at B, and then compare them. P is equal to the potential at the non-inverting. VA is the potential at the inverting. All right. But the problem is we're not sure what the value is. Okay. So I want to show you how to get it. All right. So before we do those, head up potential divider. Potential divider. Right. So I want to show you how to handle circuits that look like that. Potential divider. Huh? Potential divider. Sort of a no, but it's more an application of Tuesday. Yeah, Tuesday. We still have these two things. Yeah, and halfway on. What's first? Right? Sorry. Plain after.
Like for.
Yeah. No one time on it. Yeah, before my finish. All right. Yeah, but you can imagine me teaching this 4 weeks from now, or it'll be lost. Right? Huh? It lost right now?
Okay.
All right. So before I show you those, let's take a look at what the potential divider is. Huh? On the comparators here. Right? A potential divider. Technically, you work with this already, yeah? You all remember two resistors in series?
Yeah.
Right. What has happened? What has happened to the voltage with two resistors in series? The voltage is split up. So the voltage being supplied here splits up here and here. That's correct? Are you okay with that? How you find current in this circuit?
Easy with I.
Right? So I is V on R, right? How you find R?
R is equal to BY.
No. What's R here in this whole circuit?
Oh.
R1 plus R2.
So now part that's
Series, yeah. Add it. One is parallel is 1 over formula. Right? So the current in this circuit is this. Right? What's the current flowing here though? I want to find V1. V1 is I by R1, correct? Correct? Remember, V1 will be the current flowing here by R1, right? What's the current flowing here? Same thing. Because current in series is the same. And so V1 is equal to this, which is V over R1 plus R2 multiplied by R1. So therefore, V1 is really this. What's his formula? I'm just rearranging this, right? R1 over R1 plus R2 all multiplied by V. What it's saying is that V1 is a fraction of V. You see that? So V1 is a fraction of V. This formula helps us find it. You see that? Right. You see that? Right? All right, don't worry with all this. This is how you find V1. V1 is equal to the total supply divided by the fraction. Right? So for example, that's 10 volts, and that's 2. Right? What is here? What is here? How we get V1? How we get V1? V1 is the total voltage, which is 10 by the fraction, right? So the fraction is R1. This is always R1. Wherever you want to find V1, that's the R1, right? 2 over 2 plus 3. That's it. Right? 2 over 5. 5 into that is 2. 2 by 2 is. That's it. Okay? So the voltage here is 4. What's the voltage here earlier? Here is 4. Here is 4 too. $2 how much? Here is 10 and here is 4. How much is here? That's minus 6. And it's split up. Right? So here is 6. Okay. Are you okay with this? So that is all the voltage divider will do. Divide the voltage. Right? And that's the formula. That's all you have to understand. Right? But the problem is it don't look like that. It look like this. Same thing. Same thing. This is the 2 ohm resistor. This is the 3 ohm resistor. And you have a supply here. Let's say this is 5 volts. This is minus 5 volts. What's the total voltage being supplied here? 10. You right? See that? Total voltage being supplied there is what? 10. Right? So we are going to try to find 2 things. I am going to connect a voltmeter here. And I want V. And then I want potential at V. Copy it down and then let's see if we can find the voltage and then find potential at V. Have a great time. After this year.
So you know, you have that 12 class. You have breaking the. It's a long basis. I mentioned more to see. Listen now, yeah.
Maybe if you know there's just that correct. It's not okay.
You didn't want to get done. I wouldn't want to. I would want to something.
I'll do whatever to forget that go.
So we're gonna try to find V, and then we're gonna try to find potential.
It's not being used.
Well, I was sure.
Sorry, I do want to have this video. You're. Right.
Which one was it? Which one? Yeah. Which one?
We did. This is so fun, but then like.
Oh, yeah.
That's something to say.
Yeah, actually like. Yes.
Oh, mas que não.
Right, ready? So how we get V? V is just like when you connect it here. Technically, that's turn it sideways, right? So 10, same formula. No, the supply is 10. The total supply is here. So watch. If I connect a voltmeter here and here, and the voltmeter measures potential difference, so the voltmeter will measure 5 minus 5, which is 10. right? So when I say potential here, when I say potential, I mean the value here. I mean the value here. I mean the value here. Just the value alone, right? So the value alone at that point is 5 volts. The value alone here is -5, right? So when I say potential at A, I want the value here, right? Well, when I say the voltage, I want the potential difference. I want the difference between the potential here and here. Okay? So part 1, I want the voltage. So the voltage is 10. That's the total supply. R1 is 2. And R1 plus R2 is 5. So 2 into that is that. And again, 4 volts. Right? So the voltmeter will read 4 volts. Right? So, Nikolai, if the voltmeter reading 4 volts, right? And here's 5, what value you think here is? Here's 5. The difference is 4. So how much is here? 1. Right? So the potential at A is 5 minus 4. Are you okay with that? So Raya, what has happened there? How I get 1? And where did 5 come from? No, the potential at here is 5. And I minus the potential difference to get the value. Come on, do the next one here.
See, when you break down now.
Oh,
Stop, the question before you get ready.
yep. Huh? Number 2. This is number 2. Both of them. Cherise, I'm talking. Oh, you come and do the work here, Cherise. You was sitting in the back. Right, Saraya, you come in and do this one here. And then you can give the marker to anybody and they'll do the next one. Huh? Yes. Yep, onto this question now. Right. So Saraya, you will do the first one there, and then you'll give the marker to somebody. And then that person will give the last person. I don't know. Right. We will take probably not to work on it. Right.
I'm trying to see the movie.
I go, well. It makes it beautiful. I have to. You gotta work on this part first. Equal to what? No, no. This is the next question. Yeah, it's right equal to. Right, I know what's the potential at E.
Oh, right, okay, so 6 minus 4. Okay, I can see.
Okay, give to somebody else. Anybody do like can make them come on YouTube. Please do give it to Siri. Siri do get it wrong, eh? But the break started now. Should we shove it? Yeah, but. But then have it anyway. So you might come into play or? What? What is that?
It's the answer. 6 at 10 plus 6. Is that correct? No,
What's
not
up?
correct. Not correct.
Was that right? That's now.
10.
Or didn't look
Sorry.
like that. Bulbs. And the potential is what?
6. 10.
Yeah.
And
Minus 4. Cow, chickens. Give it to somebody to finish it out. That's not, the job too right. Yeah. Huh? So Nakila was we out. Why we do no time and we are comparing the inputs? Was the inputs are the inverting? What value is that? And what's the value at P? Right, which is larger and figure out the output. Go ahead. Think about it. Look at the beginning and comparators. Look at the beginning and comparators. How many have you seen? Yeah, you got which one larger, right? Which one larger? The value to the non-inverted or the value to inverted? E? Inverted larger. So it will saturate high or low? High. Sure. It's one of them. Guess one of them. Lower. You'll see enough? Right? And the reason why it's negative 6 volts, because you put the voltage at the inverting terminal is bigger than the voltage at the non-inverting. Sorry, I don't want to use, I say the wrong thing, it's not voltage, potential, right? The potential at the inverting is 2, the potential at the non-inverting is -4, right? So this bigger than this, so it's saturated flow. All right? That's okay? That's all that's the most important thing on this whole class. When this bigger than this, there's the answer. When this bigger than this, there's the answer. Okay? So you see how we combine the potential dividers with the comparators, right?
So basically, the top bigger is always one, minus bigger, minus.
Well, not really, because the plus sign is B here and the minus sign is B here. I just flip it over. Right? Take a break in 5 minutes. 5 minutes and then we continue. Right, Colin, so Tuesday, how are we doing this card like?
Let us see how many pairs are looking.
I can make some.
So if we get like 4 pairs, we just play in,
We just pick and write each other.
Yeah.
They do best things.
and then 2 best teams play the final.
Yeah, I'll get it. We are looking at.
Alright, well, I'll bring somebody to play, I'll get next to them.
Oh, it's on your next. I got cat, baby cats.
Give that anybody.
Você tem que ver que eu sei lá em isso.
Oh, I might give it to the kid.
What?
I didn't get it.
5 minutes, Nadia. Plug in. Right. Right, so now that we have an idea already, now that we have an idea of what's going on here, right? This is basically the comparator, right? Let's finish on that one. Ah,
So actually, 20 minutes, Mr. Vince, about.
right, so what's it here? I'm gonna connect up the same circuit I just showed you, turned on. Right. We have a circuit there, right? We need to know if that diode is on or off. Yeah, have a little LED sorry at the end. You want to know if this LED is on or off. What will turn it on? High or low? A high, right? A one, right? So a high will turn it on. So my question is use these values here. Use all your values and determine if the LED is on or off. Have fun. Huh?
What is?
Is on if the output is high. Which is positive. Yeah, Q. Same thing as do that. Except what's what's the difference between the one on the board and the one on the screen? It's connected to what? A is what?
Is zero.
A is zero. So you have to work out D, not to work out B. Oh yeah, that's fast. You don't have to draw, you don't have to draw the good stuff, right? Outside of what P is just. It's from the handle.
How about two set of folders here? So, right, right. What are the answer we just get with potential difference in P? Or verify again.
Yeah, you gotta find the potential of P.
So that is the sign.
Find the potential and find the V value first. And that the potential of the right side there. Fine. Where you? What area? I read not on that.
Taking stuff in this.
Huh?
It's human gaps as a way of so much. Gaps.
Oh, and next.
Yeah. You know, when it's up.
Because you have different business.
Yeah, gaps like one. Not that you put in.
Right, you come again.
They also want to teach. Maybe same.
Also, that one has that.
You feel like it's also they get it at that age.
So basically, the question is the LED on or off, right? So all I want to know if it's on or off. Sorry, it's more than one.
Maybe we'll repeat it more.
Wait, hello.
That's like, yeah.
If your output, if your V out is positive,
That's
but if it's negative, it's really too bad. Remember how to get V out? And you have to compare the voltage here, the voltage here. So you have to compare 0 with But again,
I guess so maybe it could be 50 minus cents what we get. We want.
so you have to work out V earlier, the same way you work it out in what?
Yes, so,
What? As the value of B,
yeah, so we then we want. Then I think.
so we all.
Because,
Wow.
no, it below, more than 0. So I need.
So I guess I'm gonna make sure I understand what you're doing, right? So you found V. Right, so that's 30, because it's 15 to negative 15 by 10 over 10 plus 2. That's a quarter, right? How much? 10.5. Right, that's the potential difference. So 15 minus 7.5 is also 7.5. So 7.5 is more than 0. So V inverting is more than V non-inverting. It's not 1, it's 0. It connected to 0. So therefore, the output will be negative 15 volts, which will turn it on. Alright? Which will turn it on. What did happen for it to be on here? What did happen for it to be on? Huh? Okay, something bigger than 7.5. Or
The
7.5 could be smaller, right? Right? Or I can make 7.5 smaller. Right. So how we can do here is make this value larger. And so if I have 30 by just making up something, right? 30 over 10 plus 30. Right? How much is that? No, not bigger than that. 22.5. And if I take 15 minus 22.5, what will happen? I will get something minus, right? Which will turn it on. Okay? So you may not have they did not do this as yet, but this here is called an LDR. It's a light dependent resistor. So the resistance is not all 10 ohms. The more light on it, it changes the resistance of it. Okay? So like the more light coming in on it, it will change the value. That's why it's called a light dependent resistor. LDR. Right? But we'll do that later on. All right, so that is your thing there. This is the one that we were doing earlier, where you had a compare, right? Comparing 0 and something else. Here's the one that we just calculated, right? You recognize that? Right? We just calculated that. Last one. Last one. You get it right. S is 200. Right? I want you to tell me which LED is on.
I have what means of that 9 volts.
S is 200. That's I want you to tell me which LED is on. Is the red LED on or the green LED on? The feel like. Or the yeah. Get to work it out. Get to work it out, then I can feel like. I know that Shirish. Right, you have to work out the potential at A and potential at B and then figure it out. Please do the work here. You can leave the diagram. Diagram is on page SS 200. Eh? The diagram is
Yeah.
number 1 on page 10. Number 1 on page 10. Ariane, you work it out? Ariane, you work out nothing?
Ariane.
Ariane just must have read it.
I'm 100% sure he would be right.
That's to be sure. See why you work it out. SS 200.
So we want, yeah, I get my.
Everybody work it out. I pass around the world. All the good. Oh, yeah, sorry, but you come on the board to the board thing. Actually, the same thing on the board. Ah. You had to figure it out. I tell everything. You had to figure it's like the last one. Not the last one. Figure out what would turn on red. Sorry, figure out what would turn on green. And the other would turn on red.
Okay, see, this negative, I'm reading it, it's possible, right?
Huh?
This negative, I'm reading it.
If one on the next one off, both of them can be on.
I get green on.
Should we shall you working it out? Yeah, and you want to go on to back end? Alright. Please work out the value, sir, yeah? Work out the value at E and work out the value at B. Right, your homework is the exam are given it. Homework is page 14, number 5. Huh? That's only hand out already. Page, yes, another group number. The homework is page 14, number 5. Page 14, number 5 is your homework. Okay, are you working it out? So why was Nikolai book so long? Page 14, number 5 is your. Huh? I'll show you that. The last thing we do, right? Right? Next day we will just delete none and go. It's
I
not.
get red ones, so sorry.
Huh? Alright, so let's work it out. I'm working out here first. Right? That will be 18 by 300 over 420. How much is that? 12.85. So that will be, so the potential here will be 9 minus, which is minus how much? No, it's 9.
Minus
Top 5. Minus
3.9.
minus 3.9. Then it's all the highest value, right? The highest value, the positive number. Then do it here again. And you'll get 18 by 600 over 800. What is that?
Well, no, 13.5. Minus 13.5.
So the value, So the value here will be 9 minus
It's minus.
minus 4.5, which is larger.
It's minus.
Right, minus 3.9 is larger, right? So BA is bigger than BB. So that means that the output, since BA is inverting, right? The output will be minus 9 volts. Right? So the LED that will be on and be red. Very good. Red is on.
Why, that's it, right? Wow.
Red is on.
Oh, no.
I feel should be, did you write it down? Yeah. I will take what please. Bring it up.
I tried those.
Because it's forward bias, it's like a diode. It's forward bias here. So a positive will turn it forward bias, right? And turn it on. And this reverse one negative will turn this one on. Like a diode. Yeah, bring it over and see. I was calling mother now, right? You can't write it down again. But let's call him mother. Here, what's that what you do? This is a hard floating outside.
You know, in compare, so what was the value? It's really negative. I don't know what to do.
What?
Compare, that was it. The value is really negative. I don't know what to do.
Are you looking log out now, right?
Yeah, it is a very negative, okay, right? It's